Okay, so what tan formulas do we know in our courses? There's tan of A plus B or A minus B. So I could use tan of 2 lots of pi on 8. I could, let's grab a pen here. I could actually use tan of 2 lots of pi on 8. That's tan of 2A, which is equal to tan of A plus tan of A all over 1 minus tan of A times tan of A. So I could use that and get straight to the answer, or I could possibly have tried tan of pi on 4 minus pi on 8 and done that expansion, you know, tan of pi on 4 minus tan of pi on 8 on 1 plus tan of pi on 4 tan of pi on 8. So looking at those two, you know, I'm going to end up with, over here, I'm going to end up with tan of pi on 8 equals 1 minus tan of pi on 8 on 1 plus tan of pi on 8. If I use that, looking over here, I'm going to get tan of pi on 4 equals 2 tan of pi on 8 on 1 minus tan squared pi on 8. Tan pi on 4 is 1. 2 tan pi on 8 on 1 minus tan squared pi on 8. This is going to give much the same thing. I think if you rearrange that, you know, like do tan of pi on 8 times 1 plus tan of pi on 8 equals 1 minus tan of pi on 8, you'll get tan of pi on 8 plus tan squared of pi on 8 equals 1 minus tan of pi on 8. So you will get two of them. Yeah, you'll get tan squared of pi on 8 and 2 tan pi on 8 minus 1 equals 0. You get a quadratic. This is going to give you the same thing. 1 minus tan squared pi on 8 equals 2 tan pi on 8. So I'm going to get tan squared pi on 8 plus 2 tan pi on 8 minus 1 equals 0. Either way, I get that equation. So I could have approached it from either way, got myself a quadratic, which I now need to solve. Hopefully the solution is whatever they've set up there, root 2 minus 1. Let's just grab a bit of an eraser and make ourselves some room to solve this quadratic. Just looking at it, it's not factorizable, but we should be able to solve it without too much difficulty. So let's have a look. We've got, let's say it was u squared plus 2u minus 1 equals 0. Then u would be minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. So it's minus 2 plus or minus root of 4 plus 4, root 8 on 2. So it's minus 2 plus or minus 2 root 2 on 2. So it's minus 1 plus or minus root 2. Now we know that tan pi on 8 is positive, right? So since tan pi on 8 is bigger than 0, tan pi on 8 must equal the positive one, which is minus 1 plus root 2. Or as expressed, i.e. that's root 2 minus 1 as they've expressed in their question there. So that's got that first part done. What about the second part? What do we got to do? Okay, talking about an inverse tan plus a tan pi on 8. So they've just told us that this tan pi on 8 bit is root 2 minus 1. I think that's just what they told us. Yeah, root 2 minus 1. Now, we know just normally from minus pi on 2, there's an asymptote, to pi on 2, there's an asymptote. That's normally what our picture of y equals inverse tan of x is. If I just grab another coloured pen, maybe a black one, I can just move that along. Because it says x minus 1 there, we know from our transformations that that's moving the whole thing translated 1 unit to the right. So it's just going to look like this, but the point is it still goes in between those values. All right, for all x, inverse tan of x is somewhere between minus pi on 2 and pi on 2. Now this question is, it's interesting. It's asking for the minimum value of a for which y is bigger than 0. So we want inverse tan of x minus 1 plus a tan of pi on 8. We want that to be bigger than 0. We want the minimum value of a that'll give it to us. So, you know, if this is minus pi on 2, it's bounded by that. So it can't quite get there, but if it was equal to it, then we'd have plus a times root 2 minus 1 for tan pi on 8. So a root 2 minus 1 bigger than pi on 2. So a is bigger than pi on 2 root 2 minus 1 in brackets. Now, just to check that that's answered the question, well, yes, because we've wanted to find the minimum value for all x of that thing. Find the minimum value of a for which y is bigger than 0. Yep. Because it'll be, if I replace this with any of the numbers that are bigger than it, like up to pi on 2, it's only going to be bigger, so have more chance to be bigger than 0. But we want the minimum value of a to make it happen, so we'll take that as its smallest value, and that'll give us our minimum value of a.